For this lesson, you need a pencil, your day 11 notes, and a ruler. Previously, we talked about being able to determine a function being even or odd with our tables. We're looking at the transformations and comparing them to see if they met the requirements for an even and odd function. A function was even when we looked at the transformations of our function f of x to see if it was equivalent to f of the opposite of x. If that was true, then it was considered even. A function was considered odd if the transformations of the opposite of f of x was equal to f of the opposite of x. We've been looking at tables, and recently we've been looking at graphs, and we want to be able to determine if a function is even or odd graphically. When we're looking for a function to determine whether it's even or odd graphically, we're going to look for some symmetry. If a function is symmetric about the y-axis, that means it's creating a mirror image over that y-axis, it would be considered an even function. So if you look at your y-axis and we drew in where the mirror is, what's happening on one side of the mirror would also be happening on the other. Here we have this function that's symmetric about the y-axis, so it would be considered even. An odd function would be one that is symmetric about the origin. In order to determine if a function is odd, what we could do is select a point on the graph on one side of the y-axis. So I could pick a point here on the function. I would want to draw a line from that point through the origin, extending it to the other side, and if it's odd, it would end up on the function on that other side of the origin. So if I do that, if I take that point and I draw my segment through the origin, I should have one that ends up on the other side. This segment should also be the same distance. So if you grab your ruler and we measure from our point to the origin, from the origin to that other point, they should be equidistant to each other. So let's check. By using our ruler from our point to the origin, it's about 1.3 centimeters. Again, if we check the distance again, we can see that it's equidistant from the origin to that next point, 1.3 centimeters. It can be any point along the function just on one side of the y-axis as you draw it through the origin to see if it's equidistant to the other side. So I had a second segment there in green. So if I measure, this is about 0.8 centimeters. And if I check on the other side, I can see it's the same distance. So this would be an example of an odd function that's symmetric about the origin. We also talked about how functions could be considered neither an odd or even. That means it would not be symmetric about the y-axis. So we look at that mirror and what we see on one side is different than the other. We can also see if it's symmetric about the origin by picking a point on the function, drawing it through the origin, and seeing if it has a match the same distance on the other side. So here we've got an example of a neither function that's not symmetric about the y-axis or the origin. So let's take a look at a couple of relationships and see if they're odd, even, or neither. So here we have this function, and again we want to see if it's considered even, odd, or neither. We want to look at symmetries about the x-axis and the origin. If I draw a line along the x-axis to check for symmetry, we want to see if something is happening on the one side is repeated on the other. And we can see that it's not a mirror image. Therefore, it can't be considered even. Next, we want to pick a point somewhere along the function. Then, using our straight edge, draw a segment connecting it to the origin, extending it through the other side. And we want to see if, one, the point does exist on the other side, and two, if they're the same distance from the points to the origin. If that's true, then it would be considered odd. So if I draw my segments in and I measure with my ruler, this piece and this piece are equidistant, so it could be an odd function. Again, it could be any point along the function as long as we're drawing it through the origin. If it's odd, we should get one equidistant on the other side. So here we've got an example of an odd function that's symmetric about the origin. Let's take a look at one more. Here we have a function drawn. And again, we want to look at some symmetries. Symmetry along the y-axis and also with our origin. If we look at the y-axis as where our mirror is at, and we compare what's happening on one side, we can see is not happening on the other. So it's not symmetric about the y-axis. Again, we want to pick a point on our function and draw it through the origin to see if it's repeated on the other side. And we can see for any point that we pick along this function, if we draw it through the origin, it doesn't have a match, the same distance on the other side. Since both of those symmetries do not exist, we would say this function is neither symmetric about the origin or about the y-axis. Here's another function. And again, we want to try our symmetry tests. So if I look and draw my mirror, my line, along the y-axis, we're looking for symmetry here at that mirror. So what's happening on one side of the mirror is it happening on the other. So if I look my mirror here, I can see what's happening on the left is also happening on the right. Since there's symmetry along the y-axis, we can say that it's an even function. Now it's your turn. You are going to stop the video and go to Socrative.com. Enter a class code and your full name to take the quiz. Answer questions A through H that are on your Day 11 packet into Socrative.com. Do not close your browser window until you've completed all of the questions. These will be graded and entered into PowerSchool. As you're answering the questions, please make any necessary corrections to your responses on your note packet. At this point, stop the video and begin your Socrative.com.